Good afternoon. Thank you for joining our fourth and final panel of the day covering charging infrastructure for your electric truck fleet. We will hear presentations from Wendell Companies and Black & Veatch. I'm Craig Jackson, the Clean Cities Coordinator of Clean Communities of Western New York. We will finish with a Q&A session at 3:10 and wrap up the day by 3:30 p.m. I want to make some quick introductions. First is John Havrilla. John Havrilla is the Director of Alternative Fuel Services at Wendell, which provides consulting, design, and construction services to public and private organizations looking to build alternative fuel facilities for their fleets. Russell Belos is an Associate Principal and Electrical Engineer at Wendell with more than 13 years experience in electrical design. His design experience includes battery electric vehicles and charging infrastructure. Keith Dickerson is the Director of Transformative Technologies at Black & Veatch. Keith's focus areas include planning and building sustainable transportation and distributed clean energy infrastructure. And finally, we have Alex Betancourt. Alex Betancourt is the Senior Managing Director of Management Consulting at Black & Veatch. Alex is a recognized thought leader in the field of grid modernization and a pioneer in fleet electrification. So I thank all the presenters for being here today. We're going to start with Wendell's presentation. So I ask Keith and Alex, go ahead and mute yourselves and you can turn your cameras off at this time. And I will allow John and Russ to go ahead and take the lead for the rest of the presentation. Thank you.
Thank you, Craig. If you could advance to the next slide. And the next slide. I don't know if any of you have had a chance to look at Tony Seba's Clean Disruption of Energy and Transportation, but it's an interesting presentation if you do get a chance to take a look at it. One of the slides that really intrigued me was a picture of Fifth Avenue in 1900. And if you look at the picture on the left, there was one car on the street in 1900 on Fifth Avenue. If you looked at the picture on the right, in 1913, 13 years later, it was all cars, only one horse. And battery electric is going to be a similar transformative and disruptive thing for our world, and battery electric vehicles are here to stay. Next slide. Next slide. There are various charging options. Wendell deals a lot with battery electric buses as well as heavy duty vehicles and light vehicles. We cover the spectrum. So some of this presentation will apply to across the spectrum. But charging options, for instance, on transit vehicles, pantographs are used a lot for en route charging. They provide a high capacity charge, typically in the 500 kW range. Pantographs are typically high maintenance, particularly in winter climates. They can be used for en route charging, difficult to install in existing depots due to the height. May reduce battery size because you can use smaller battery sizes if you're going to do en route opportunity charging. Another option for fleets is the inductive charging, which is becoming more and more popular. It again is a high capacity charge, typically in 300 to 400 kW range. There is a large footprint of associated equipment, transformers, switch gears, etc., but it can be used for en route charging. Vehicle placement is critical to the efficiency. You've got to get onto the pad correctly, but they've been improving that, and there are technologies to help the driver get centered properly. This also may reduce battery size. There are no moving parts, there's less maintenance, and it's very easy to use in winter climates. Then there's always the old fallback of plug-in charging. Simple, low-cost option, manually operated, low maintenance. Placement in tight garages can be a challenge. However, Wendell has been working with real systems to drop down, as well as swing arms and a bunch of other different options to do in-depot charging from a standard charger. Can be used on both en route and depot charging, and chargers are similar to other options. Next slide. We have used a lot of Proterra chargers on some of our projects. The Proterra chargers come in 3 different sizes for the Proterra buses, 60, 125, and 500 kW size ranges. A lot of times in the depots we'll use 60 to 125 kW, depending upon the timing of getting the fleet out, and an en route is usually the 500 kW. Next slide. ChargePoint also manufactures similar size chargers. They can do 62.5 kW, 125 kW, and they can also do 250 kW. 500 kW is the maximum that they go as well. Next slide. More recently, we've been using the ABB large vehicle charging systems. This is a fairly nice system. And if you can see, it goes from 100 to 150. The 150 also can use 3 dispensers connected to 1 charger to sequentially charge 3 vehicles, which is a nice feature of the ABB charging system. Next slide. And we're going to go into some case studies. And with that, case study number 1, I'm going to hand it over to Russ.
Thank you, John. Thank you all for joining us. So this afternoon, we wanted to present to you a few examples of some of our recent transit projects that we have completed or are currently finalizing the design. This first one is Greater Bridgeport Transit. After the immersion process, it was determined that the client, they didn't want to go past their spare ratio, which was 11 buses. We always like to a number because that gives us a target. So that gave us a target to shoot for, and after analyzing the existing electrical demand at the depot, which was actually 119 kilowatts, it was determined that the electrical service upgrade was needed, to accommodate the additional 1.5 megawatts worth of power. So our team, has designed the new electrical service, which included main switchgear replacement as well as the service transformer. The next slide is showing the impacts of what this project has caused on the power distribution system. Here's a single line diagram of electrical equipment prior to modifications. Pretty typical for bus maintenance facilities. It consisted of 1200 amp switchgear and a 500 kVA ped mounted transformer. So looking at the equipment, we determined that it was not large enough and would need to be changed out or replaced to accommodate the addition of the chargers. So the next slide shows after the modifications, you could see the equipment that's kind of outlined with the red boxes. That's the additional equipment that was needed to accommodate the charging. So we went from 1200 amps switch gear to 2500 amp switch gear with 1500 kVA transformer from the utility, triple the original size. And again, the red boxes indicate the new equipment. So we knew 11 BBs was the goal. And after discussing the project with the local utility there, they advised us that the maximum service that the utility would be able to accommodate could only handle 6 chargers, 6 buses at the same time. So we settled on 125 kW chargers, and the reason for that is we knew that they would charge a bus in about 4 hours versus a 60 kW. So that gave us a flexibility to fully accommodate 11 buses within an 8-hour charging period. So we were going to stagger them, charge 6 and 5, one group after the other. Larger chargers take up more space, and after reviewing a few options for locating the chargers, it was determined that the best would be to locate them outside and have the remote charging dispensers on the inside closer to the vehicle. The next slide shows the typical configuration, charger and dispenser. The photo on the left is the dispenser that was located on the inside. The one thing I wanted to bring your attention is the swing arm design. So one of the things that we wanted to do is have because these buses are going to be plugged in for 4 or 8 hours at a time. We wanted to get the cable out of the aisle path. The striped area, it's kind of hard to see, but the striped area right in front of this dispenser on the left is a code mandated egress path, throughout the building. So we utilize the swing arm design to get the cable out of the way, so it's not a tripping hazard. And one other thing that I wanted to bring your attention is a lot of the charger dispenser combination, they have cable length and equipment distance limitations. You could see for a Proterra charger, it's about 492 feet from the charger to the dispenser, and then about 25 foot from the dispenser to the actual outlet on the bus. We found in our experience that this is pretty close across the board, ABB, Proterra, but there are some variations, and a lot of the manufacturers are willing to work on the cable lengths, to be project specific. So the next slide shows the facility plan of the facility. It shows the charger layout. So you could see that, because we were going outside with the chargers and dispenser in the inside, we chose to sort of have 2 dedicated lanes, if you will, or 1 and partially second dedicated lane for the chargers. Those are located on the outside walls, so the first phase was to include partial charging, not all 11 buses, but because of all the planning that was done, switchgear replacement and service accommodations, going up to 11 buses would be relatively easy. So the next slide is the case study number 2. This is for CT Transit for their Hamden, Connecticut facility. So our team did a facility electrical demand analysis, and it was determined that there was enough capacity in the existing services and the main switchgear to support charging of the 10 buses. So our goal was the 10 for this first phase. Actually the facility is supplied with 2 equal services, so 5 chargers will be connected to each. And John has a couple slides that are coming up next that he's going to discuss some of the assessment specifics that we did for this facility.
Next slide. So the current loads at this facility were 1.18 peak megawatts, and we were adding a significant amount of load to this facility. The costs for the build-out, CTDOT required that CT Transit go to 100% battery electric buses by the year 2030. And you can see the table on the right what some of the costs were. Those are cumulative, you add additive at each step. So it's about $16.8 million to upgrade the facility to go to 100% battery electric buses. And the utility had to make an investment, or will have to make an investment, of about $27 million in the utility infrastructure that feeds the facility. Next slide. So the buses add about 18 megawatts if you were to charge them all at the same time. We're charging half the buses at any one time, so we're about 9 megawatts worth of power. And we looked at how this would be done in 5 steps. And you can see in the table on the right, we're using all plug-in chargers until we hit about 50%. Then we have to have some en route charging, and we eventually start doing induction charging as well. These buses get about 149 miles of range out of a 327 kilowatt hour battery. It's actually a 440 kilowatt hour battery rated, but it's an actual consumption of 327 kilowatt hours. Next slide. And I'll turn it back over to Russ.
So this ended up being a relatively easy project from the electrical point of view. You can see all that we're doing is providing new charger panel boards and connecting them to the existing service equipment. As John mentioned, we were also tasked with analyzing 100% fleet electrification. So the next slide shows how the distribution system has to grow to accommodate that much charging equipment. So we went from the previous slide to this slide. You can see just how physical equipment would have to be added in order to accommodate that. The total load would be about 10,800 amps of charging at a time. So the next slide shows kind of a planning diagram, that we look at when we, recommending designing or starting design of a electrification projects. This sort of indicates the potential location of all electrical charging equipment. Unlike Greater Bridgeport Transit, there was enough room in the bus storage building. So we have, designed an all-indoor charging, which did require some fire protection system upgrades. So we had to design a dedicated fire pump service with natural gas generator for backup. After 50%, like John mentioned, there's no way to accommodate plug-in chargers. So, there's no available space to utilize plug-in chargers. So induction was considered and recommended at this facility. You could see, the greener lines or greenish lines representing the lanes where induction chargers would be utilized. So next slide, please. Which is case study number 3. So similarly, this is a CT Transit. This is for their Stamford, Connecticut facility. There we're designing a charging system for up to 5 buses for the current phase of electrification that they're proceeding with. Looking at the facility electrical configuration, it was determined that new service would be required. The immersion process revealed that they could possibly wanted to get up to 30% fleet electrification in the very near future. So our team is designing a new electrical service to support charging of up to 22 buses. There is no space in the inside of the bus storage building, so the chargers, were decided to be located outside with remote dispensers and a reel, overhead reel being the only ones provided on the inside of the building, located close to the buses. Similar to Hamden, we're also designing new fire pump service, as well as supporting some other HVAC system, modifications because of introduction of the battery electric buses. So the next slide is case study number 4. This is for at Pioneer Valley Transit Authority in Springfield, Massachusetts. This electrification project has been recently completed as of this past June. This is a relatively new bus maintenance facility. It's about 2 or 3 years old. Actually, Wendell was a lead architect and engineer on the project. So we knew that the client wanted to pursue electrification, so we built in capacity and infrastructure when we were designing the building. So currently they only have a couple BEVs, but wanted to purchase more. So we designed a 660 kW charger system, which was again connected to existing electrical service, and also the electrical service was designed to accept a future photovoltaic system, roof-mounted photovoltaic system that the client was going to install later on to help them offset some of the facility electrical demand as they keep growing their fleet. The next slide is a WRTA in Worcester, Massachusetts. This is one of the older electric bus charging projects that we've done. This facility has been operational since about 2013. It's located in Worcester, Massachusetts. We have designed an en route charger, which is a 500 kW piece of equipment. You can see it on the left of the photo with the 2 exhaust fans extending above the screen enclosure, and an inverted pantograph charging system. The charging head is was integrated into the canopy, and it drops down once the bus pulls up and the passengers are coming on or off the bus. It required a dedicated electrical service equipment that was provided, that was provided for the building, for the facility, as well as the charger itself. The next few slides here show sort of some of the more typical charger dispenser configuration for the interior. Upper left shows a charger and dispenser as a single unit. Upper right shows a charger farm with remote dispensers, such as the one pictured below, that would be located near the bus charge port, the vehicle charge port. Next, the next slide shows a typical exterior charger farm, and I like this photo because it shows all of the typical equipment that charging would require. From the right to left, you see the transformer, you see the service switchgear, charger panel board, and the chargers themselves, with on the leftmost side with remote dispenser being visible there at the end. The next slide shows the rest of the dispensers being located or spaced out every two parking space spots outside in the parking lot. So if you plan it right, there's nothing to be scary of electrification. The next slide, I think, John, is.
And the other thing we try to do when we look at a client and look to electrify a facility, and one of the key points here for CTDOT was they did not want to do en route charging. They were very much opposed to it. So we had to stay within the facility and do depot charging. But we also look at what are some of the opportunities. And so fuel cells, there is a fuel cell at the Hamden facility. So we look at fuel cells, solar arrays. For transit facilities, it's fairly easy because you've got a large parking garage, especially in the Northeast. If you're a transit agency, you park indoors, you have a large garage for which solar arrays can be used. Battery storage is a thing that we look at as well. Generation is unfortunately not a good option for backup generation for charging buses because of the size of the load. But we do try to augment with alternative energy systems as we move forward. And with that, the next slide, I think, is the end. So with that, we'll turn it back over to you, Craig.
Great. Russ, John, thank you very much. Great job. And yes, we'll hold the questions towards the end for the Q&A panel. There were a few questions during your presentation, so we'll have some discussion for everybody afterwards. So coming up next is Black & Veatch. We have Keith Dickerson and Alex Bencourt presenting now, and I will turn it over to you gentlemen. Well, as soon as Keith comes on, I will. Great. All right, guys, I'll let you have it from here.
Okay. Good afternoon, everybody. This is Keith Dickerson with Black & Veatch. I've got my colleague Alex up in Canada, and we look forward to get to know y'all better and talk about a little bit more about charging infrastructure. Nice job, Wendell team. Very, very well done. Next slide, please. Next slide, please. So Black & Veatch is a 100-year-old engineering construction company. We focus on what we call horizontal infrastructure. So things like power, water, telecommunications is within our wheelhouse. We're a large organization, 10,000 professionals across the world. One of the things that I really like to focus on is safety. I'm a Coast Guardsman, saw a lot of people do a lot of silly things over my time there. So one of the things that really attracted me to Black & Veatch is our safety ratings. We have best in class, but also what's also important from a social equity standpoint is our diversity ratings. We get some of the best ratings within our space. Next slide, please. So like John had mentioned, we're in a transformational time right now. Infrastructure is really becoming more distributed and deployed closer to the point of use. So you imagine 5G technology, charging stations, solar, battery storage, data centers. In the case of edge data centers, they're all really becoming deployed closer to the point of use. And that creates opportunities and challenges. I think the key thing when you look at all of those ecosystems really is look at the utility relationship, look at the providers, in the case, let's say the carriers, but the coordination amongst all those stakeholders is extremely, extremely important. But for the purpose of for this presentation, we're going to focus on that utility coordination and relationship piece. Next slide, please. So Black & Veatch we're very well established in New York State. We actually have a primary hub office in New York City, in Manhattan, and execution and project sites all throughout the state. We're actually I'm not sure if we're the newest, but we're certainly a newer member of Empire Clean Cities. And I'm especially excited to let the folks on this call know that we are an approved contractor for the Joint Utilities New York State Make Ready program. Timothy Ferguson from National Grid was talking about that earlier in the day. So that's something that we're excited to be a part of. Next slide, please. So what do we do? We're a full service engineering, procurement, construction company. But I think what's important to look at when you look at this slide is really kind of focus on the left side, far left side, in terms of the planning piece of it, but also the operation and maintenance side of it. My colleague Alex is going to outline some elements, particularly on the planning piece. So it's going to really be very important to embrace that piece of it. Of course, you know, we love the engineering side of it as well, but the planning is something we really look to our clients for. Next slide, please. So clients like Tesla, Electrify America, we've deployed some of the largest and highest power requirement to charging stations and deployments in North America. Next slide, please. And as you see more medium and heavy duty and transit systems coming online, you're going to see a big push, almost a competition for utility capacity, particularly in logistics centers and depots. So the ability of the grid to provide utility capacity, the required resiliency really are sometimes exclusive. So more and more end users are considering on-site generation, distributed energy resources such as solar and fuel cells. Again, what the folks from Wendell were talking about, and transitioning into microgrids. So with that, I'd like to transition the presentation to Alex. Alex, you got the ball.
Thanks. Next slide, please. Hello, everyone. So what I want to talk about today is sort of around the strategy of building that charging infrastructure. You know, Wendell did a great job of showing you exactly, you know, what that infrastructure looks like and you know, even cost estimates of those larger scales. And I want to sort of go right back to the upfront planning for it. You know, there are a lot of fleets out there that are looking at electrification. And some of them are looking at electrification in the short term here for sustainability reasons, and it's for good reason, right? When you look at the amount of greenhouse gas emissions that come from freight, you know, it's one of the largest portions of greenhouse gas emissions. In Canada, it's, you know, similar to all the electricity that gets generated, and in the U.S., it's still about 10% of the overall emissions. And so, you know, you see, you know, people like FedEx and Walmart and Pepsi, you know, making pretty aggressive announcements on electrifying their fleets. And that's around sustainability. But we don't think that that's going to be what drives people to, you know, make bulk changes to their system. We think it's going to be the economics. So if you go to the next slide, please. You know, there is an overall change that's happening in transportation. And, you know, a lot of people who are getting into this, people who've been on the power side of the business, you know, transportation is new. And when you look at transportation, you know, there are 4 key trends that are going to change how, you know, the economics of transportation. Electric is definitely a piece of cost savings, And we'll see later on how much we think that cost savings is relative to the other pieces of cost. But also, these vehicles are getting more connected, right? Real-time telemetry, faster routing. Everybody's seeing the vehicles come up and down the road with packages. All that is based on them being more connected and data-driven. We talk a lot about electrification here, but the biggest single change that's going to happen in transportation is going to be autonomous, especially around fleets. When you look at the cost of running a fleet, the fuel is going to make up about 35 to 40% of it, but the driver is going to make up 45 to 50% of it. And so a lot of fleets are looking to go autonomous because A, they're having a lot of fleets are having a tough time finding enough drivers for those routes, and B is because it's their biggest cost component, especially on the long hauls. And we think that while it doesn't have to be linked, a lot of people link EV and autonomous, and so we sort of see that trend coming in. And the other one is shared, right? You're seeing fleets being used by multiple parties, right? You see outsourcing of fleets. You're seeing vehicles being used more hours in the day. And so all those things are sort of contributing to a wider transformation in transportation that's making it more efficient. And electric is a key component of that. Next slide, please. The capital costs are higher. And it's interesting, over the course of this fall, I've seen some data points come out, and the Ford one actually really surprised me. Ford came out with their e-Transit, right, their electric version of their transit delivery van, at a price of only $45,000. And we've seen other makers of those type of vehicles come out with prices that are just slightly above that, right? Mercedes and others. On the Class 6 and Class 8 trucks, there's not a lot of published data. The most famous one is the Tesla Semi, and it's coming in at about 50% cheaper, 50% more expensive. And so that's the economics, right? Can electrification pay for this premium of the capital? We've been studying actually quite closely where we think that the price parity is going to be for those vehicles. For the vans, we sort of see price parity at that 2025 mark. And for the larger trucks, we see price parity at the 2030 mark. And that's based on a bottom-up assessment of the battery electrics that go into those vehicles. Next slide. We've talked to a lot of fleets, some of the early adopters of fleet electrification, those bus fleets that Wendell was talking about, a lot of commercial fleets. And there's some universal, almost universally, those clients talk about it being hard. When you move from a diesel or gasoline powered fleet, all that technology, all that infrastructure has been around for 50 plus years. It's not something that anybody has to worry about. But moving to an electric fleet and all of the utility interconnections and charging infrastructures and making sure the cable is in the way of the egress point, all of that makes it hard. And we're seeing a lot of fleets, for those who are anticipating it, right? While the economics really do quite pan out well, it's in order to scale it, to really do this across your fleet, it takes quite a lot of resources, a lot of planning. And Keith is going to talk a bit about that, sort of like how far in advance should you start planning. But it is a more complicated route to go electric than it is for diesel. We think that it's still economic, but it's something of an endeavor to undertake. Next slide. Charging costs at any particular site are unknown, and I've walked into a lot of fleets, and it's a frustrating answer to give. And it's because every site's a little different, and you never know quite how much space is on the local utility feeder or upstream at the local utility substation. And so, while fleets are looking to do their planning on, electrifying and how much capital will that cost up front, until they sort of get the load letter they get their load letter in and they get their utility letter back saying about the infrastructure and they get a site design created, it's hard to come up with a solid charging cost. But in general, on average, based on our experience, we sort of see this division of cost, right? About 40% goes into the chargers, about 30% goes for grid infrastructure once you get above a certain threshold of charging. We're talking broad charging of fleets, and about 30% for the on-site make ready. Next slide. right? And one of the key things that we look at is, well, where's the value? And when you look at the total current spend on petroleum vehicles, and so we did a study over a 15-year period, and we looked at $1 billion of spend for petroleum vehicles and how that would have stacked up when we moved to electric. And in that petroleum vehicles, the spend is for the diesel of the petroleum, the vehicle itself, and the maintenance of that vehicle. That's what makes up. There's only really 3 parts of that equation. But when you look over to the electric, there's a lot more tiers. It's a more complicated offering. And one thing as an industry, I think we need to be able to make this easy for the fleets that are looking to electrify, to make it as easy as just filling up with gasoline. But when you look at the vehicle between the electric vehicle lease, which is higher than a diesel or gasoline powered vehicle lease, and the maintenance, which is lower, that's about 40% the overall cost. Right? When you look at the actual infrastructure, upgrades to the grid, the chargers themselves, the make ready, the maintenance of those, and the software to control it all in order to get best optimization, that's another about 20% of the cost. The energy itself is another 20. And so some people get really surprised by that. But electricity really is more efficient at moving these vehicles around. And so 80% of the cost allows you to sort of come to that the new stack, and that leaves about 10 to 20% in savings for the customers. And then for anybody who's operating a fleet and you're looking at your TCO calculations per mile and you're trying to shave pennies off of it, something that provides you a 10 to 20% savings on your TCO, that's compelling. And so that's why we're seeing fleets really dig in and investigate that. However, it's something that requires some planning. Next slide. One of the reasons why it requires sort of this foresight and planning is that, there's only so much capacity to go around. There's going to be a competition for electrons. And so this is an example in Canada that I recently worked with, right? And so this is just outside of Toronto, right? And so, you can see that, where it says that Challenger, that's a massive, one of the bigger truck facilities in Canada, a big logistics center. And if they were to electrify their entire fleet, just like that bus fleet that Wendell talked about, it's a 25 megawatt facility, right next door. And when you think about logistics centers, they locate near one another because A, real estate was cheap there, and B, it had easy access to the highways. And so they typically congregate because of those 2 facts, which means that the power demands are going to be congregated as well, right? And so just in this particular area, if these 3 facilities, and there's more facilities on this map than just those 3, but if these 3 facilities just electrified, well, we're talking about 55 megawatts of load. And so just from an electrical perspective, that's about 1/4 of a substation in order to facilitate just that. And so it's unlike, it's possible that the local substation can meet that load, but probably just barely. And then as more things get electrified, it becomes more problematic. Next slide. So key takeaways from my part is, 1, look at that utility relationship, right? And this is true on both sides of that equation. Fleets need to see the utility as a key supplier, just like they see their fueler. And utilities need to start seeing those fleets as key customers, just like they did the steel mills of the past. Planning ahead, making sure that you have it in your plans. And when we say like ahead, I mean 3 to 5 years ahead, so that you can incorporate, the fleet purchases, any power required, etc. And then get that grid capacity early, right? If you are looking to electrify, it's important that you apply for that grid capacity now and start building that charging infrastructure in a way that gets you access to that sort of cheaper grid capacity. Next slide. With that, I'll pass it back to Keith to talk a bit more about that.
Thanks, Alex. Next slide, please. Yeah, so to Alex's point, there are different time frames relative to getting the power that you need. So actually what we've done is we've looked at some sample fleets, what the capacity would be to get to that place, what's the level of upgrade, and the typical timeline. So for example, if you look at the smallest size fleet, the potential upgrade could be a service transformer. That would be your pole or pad mount transformer that you see all the time. And typical timeline is 3 months. Start getting larger, going into something in the 5 megawatt range, you're going to start looking at a feeder upgrade, which basically is a new line coming into your facility with the appropriate timeline there. And then when you start getting to the 20 megawatt phase of capacity, you're really going to start looking at substations. Now, substations for the layperson is what you would see those, we used to call them big gray boxes in a previous life of mine, that are surrounded by fencing and take transformers and switches and circuit protectors, and are really a big investment on the behalf of the utility, and that's easily going to take 2 years or more to get that place. So to Alex's point, getting those permits, those applications in early are incredibly important. Now, the one aspect of it that always comes, and it's different from different jurisdictions, is who pays. The key takeaway on something like that is to really focus on your make-ready programs. Again, as National Grid was talking about earlier in the day, there's going to be a fair amount of money going in. Right now, it's obviously for more on the light duty, but there are some medium and heavy duty make-ready programs that are coming up. But the key thing, always, and the message that we want to send is contact utility early. Next slide, please. So what we've done is take the learnings of the last 5 or 6 years in our deployments of fleet electrification, and really kind of brought it down to these steps. So just jumping right into the pool, one of the things, if you look at step number 1, where you're evaluating how the infrastructure is going to, or how the vehicles are going to be considered. Had an example where the transit agency got a slew of buses, about 60 buses, and they didn't choose to do an operational study. So what happened is they ended up putting in really extra charging stations, 1 charger for every single bus. Had they done evaluation of the routes, they could have probably significantly reduced the number of charging stations and had the impact into their depots and on-route charging. So that's really the first step, is understanding how the vehicles are going to be used. Component number 2, technology. I really look at this from several different lenses. Obviously, the vehicle type and the use cases are really paramount in terms of the technology piece of it, but also from an infrastructure perspective. You need to look at the different charging capacitors, the network that they may use, how they're going to be integrated. So I kind of look at the vehicle and the infrastructure in that technology piece. Another important aspect of it as well is the operation and maintenance. Again, there's the vehicle piece of it, but there's also the operation and maintenance of the infrastructure piece of it. So once you get to step number 3, you're really going to have a really a good understanding of the charging load profile and the power delivery requirements, and it's that nexus of those things where you can then start going on your site planning. So what you're doing from a site planning perspective, is both civil, electrical, general constructability. Things that I've learned in this role is things like vehicle flow. How would you take a finite piece of real estate and reconfigure it for something that might have been set up for compressed natural gas, diesel, what have you, where you have an infrastructure, you have to kind of really reimagine the whole facility. So that site planning piece of it is paramount. Once you've got that site plan, then you really start going to the utility coordination and in the engineering piece. And this is the point in which even though you're being proactive and leaning into the utility coordination piece and the applications, this is the juncture in which you have that information to go to the utility and go through the engineering process. Typically what we do from an engineering process, it's an iterative, where we work with the client and go through certain phases. So we'll do a design that we call a CD30, construction drawing 30% complete. We'll have the stakeholders review that. We'll go to a next stage of 90%, again, approved. And then we take that and put it into a what we call a CD, which is ready for construction, where we'll actually go ahead and apply for the permits with the local jurisdiction. Now, the jurisdictional piece of it is very local and nuanced. If you look at what happens in New York City as opposed to other parts of the state, New York City has neighborhood requirements. A task called expediter is typically required in New York City and other parts of the country as well. It's not just New York City, but that tends to add extra layers of cost and time. Another aspect that we've seen a lot in this unfortunate world the last 10 months or so has been the COVID piece of it. The utility, or excuse me, the cities, the authorities having jurisdiction might have had a manual process where you actually had to go into the office and apply. They might not have a online process because right now they can't accept people in their office. So the COVID's been a big piece of it. The key point is having partnership with a land services professional. That's something that is a key element. That's a big part of what Black & Veatch does, whether we're doing cell phone towers or distributed energy infrastructure such as charging, where we're doing a lot of multi-sites, is making sure you have somebody that understands those local requirements, whether it's zoning, inspections, again, those other elements that I talked about. Next stage is hopefully this is minimal. Hopefully you're in you're deploying in an area that already has a robust power, it can provide it resilient in a large capacity. But hopefully, those distribution upgrades are not required. And then finally, the last step really gets into the procurement, execution, and commissioning piece of it. You look at construction; it's always fraught with situations you weren't aware of. So, for example, New York City, because it's been a city built upon layers and layers of infrastructure, you're going to have surprises. Another element that's very, very important is equipment lead times, not just for the buses, but for the other pieces, the charging stations. As you get into larger power requirements, the switchgear and transformers become more customized and have a longer lead time. So it's important that you have a partner that understands how to make all these moving pieces coming together. And then the final piece of it, really, of all these elements, whether it's the vehicle, the equipment, the jurisdiction, the power, you all want to have that to the place where it's done, so that when you're doing the commissioning piece of it, bringing in the buses, testing it with the charging, making sure that it's certified by all entities, you get to that place where you're done. So with that, I do have next slide that's a little bit more detailed into the fleet electrification journey. But that we can table that and maybe go on to questions if you'd like.
Great. Thank you, Keith. Thank you, Alex. So we'll go ahead and allow John and Russ to join us as well. I appreciate everybody for your presentations today. And I'm going to go ahead and encourage our attendees to also enter any additional questions that you may have. We have quite a few to go through here, guys, so let me go ahead and get started. The first question, I'm going to go ahead and open this to the entire panel. And the question is the lack of 480 volt capability in some rural areas a big issue with charging vehicles?
480 in rural areas?
Yes.
That's something that's doesn't. I'm not sure I've ever heard of anything like that. I mean, a lot of times in rural areas, you may have industrial facilities is not uncommon. But I'm not.
Yeah, in our experience, I mean, 480 is just the voltage level. It's more or less you have to look at if the circuit could handle, amperage and, the addition of load. I mean, residential or rural areas, they're long distance, low amperage, type distribution. So, I mean, it's a transformer that you could grab from the pole to get 480 to power up the equipment. So, it's not a big deal. I think you have to look at the circuit feeding, your charging location.
Yeah, I think the actual question is probably less about the 480. Yeah, sorry. The question is probably less about the 480 volt and more about the three-phase power. So to get high power three-phase power, to get high power charging, you need three-phase power. Right. Your home and my home is probably served by a single-phase circuit, and it's going to be some areas where there's only single-phase circuit and the closest three-phase power is a mile away. That does cause problems.
Good. So that would be something during the design phase to take into consideration, right?
Yep.
Next question is a little bit more specific, and I think this is directed towards the Wendell team. They ask, for the Pioneer Valley project, how much cheaper do you believe it is to design charging into the building during the build rather than retrofitting?
I'll let Russ answer that one.
It all depends on when you plan on, introducing electrification. It's always it's a market, that's in flux. There's always more efficient pieces of equipment that are coming out with different options. So you could plan for it, but it doesn't mean that it's going to be there if you plan on electrifying in 5-10 years. And I'm talking about more on the power distribution utility side versus inside the building. I think if you have a plan to electrify, it always, if you're building a new facility, it's always better to have it built in, a breaker space, your switchgear size large enough to handle. If you know what the end product is going to be, it's better. If you don't know, if it's a lot of flexibility and you're just planning on the biggest system and it doesn't happen for a while, it probably doesn't make sense to spend the money. As far as specific numbers, it would be a shot in the dark to pinpoint anything like that.
One of the biggest issues.
Anything to add, John?
Yeah, one of the biggest issues that we face is that this equipment, the breakers, the transformers, the chargers, all take space. And in an existing facility, space is always a premium. So it's where do you find space for this equipment? And you can plan on it a little bit better if you're building a new facility. But even then, space is always constrained. And you just have to plan on the fact that if you're going to electrify, you need to find space for a lot of this equipment.
Right. So building off of that, John, actually, another question was, in planning moving forward, what can companies do to facilitate the installation of EV chargers in the future? Now, I'll open this question to everybody on the panel.
Well, I think Black & Veatch is right, and we do similar things, and that is you have to work with the client, you have to work with the utility to set out, all right, what is that strategy? You know, how fast are you going to electrify? How many electric vehicles you're going to have in the next 3 to 5 years, 5 to 10 years, 10 to 15 years. It's a little easier on a transit agency because their vehicles have a 12-year life and they have a cycle that they replace them on, so you can really plan out what does that look like. And then you can work with utility. And, you know, one of the things we try to do is make sure we come up with a plan whereby we're not disposing of equipment that we put in year 5 because we got to replace it in year 10. So it's really coming up with what is that stepped sequence, and it's based upon what your plan is. And then the other piece, the wild card to that is technology is changing so rapidly. Battery technology capacities are increasing almost double every year, is what we've been seeing. Chargers are becoming more efficient. So, you know, it's hard to take into account, you know, what type of step changes we're going to see in technology as we move forward. But that's basically my perspective on it.
I have a slightly different view. The technology is going to get better over time. We're going to be able to charge things at 1 megawatt and above. You're going to see that bus be able to charge in, you know, in 2026, that bus will be able to charge itself in 20 minutes, and it'll be fantastic. But a lot of fleets, you know, what they do today is what they'll do tomorrow, right? And a lot of fleets sit there all night long. And, you know, that old-fashioned 15 kilowatt level 2 charger that works today, it'll work 10 years from now, right? Because that van is still just going to, you know, do its 50-mile run every single day. And so I think, you know, if fleets are looking at, say, like, you know, it's like waiting for the next iPhone or the next version of the TV. I think if it works for you today and the chargers that you put in today, my guess is that that charger will still serve you 10 years from now, right? Because, you know, your van is still just doing its 50-mile run, right? That van might become autonomous 10 years from now, but the charging will be about the same.
Good. Well, here's another question for you. And I'm actually I have 2 questions here that I'm going to group together, guys, because I think that they could go together with one another. The first is, do you have any thoughts on demand charges? And the second is, can you speak to the strategies for sourcing energy, such as microgrids, battery storage, the grid itself, and does the vehicle manufacturer impact the fleet's options for optimizing energy use? We could start with Black and Veach on this one. How's that sound?
Sure. So it's interesting. So, you know, we've been working with lots of different fleets, and it actually surprises me how many fleets are back at home at 4 p.m., right? And so, you know, a lot of fleets go out in the morning, they sort of come back, you know, they're not coming back at 7 p.m. They're sort of coming back a little earlier. And so solar doesn't make a bad match, right? You sort of get some good peak solar to offset the charging that those vehicles are going to have as they come back in that early afternoon. On the demand charge side, you know, there are some utility programs out there, you know, outside of New York that give sort of demand charge holidays. I don't think you can bank on that. I think you have to, you know, make sure that you factor into the business case that you're going to have to pay demand charges. But, you know, just like, you know, Wendell was using the buses, they're only trying to charge half the buses at a time. You know, I think there's opportunities to manage the charging of those vehicles to keep demand charges as low as they can. But even when we factor in demand charges, it's still cheaper to run a truck on electricity, right? There's opportunities to reduce those demand charges. And, you know, in Ontario where I am, you really pay for peak, right? You could reduce your electricity costs, all in electricity costs, by 80% if you can avoid the peaks. You know, I think the regime in New York State is less incentive for that. But, you know, I think it's just a matter of using software and operations. But whenever I've talked to a fleet manager, they don't want to change the way they run that fleet. You know, they've optimized that fleet already. You know, you talk to a transit operator, they've already optimized the operation of that fleet. And so in general, the charging is going to have to match the characteristics of the fleet today.
Yeah, I would agree with that. I think in Connecticut, the demand charges are fairly high. And, one of the reasons why they did not want to look at en route charging was looking at 500 kW point chargers located throughout the territory, hitting a peak demand. And, so we balanced, do you use 60 kW chargers, 125 kW chargers, 150 kW chargers, and what can you do to sequence and do smart charging within the depot to charge those vehicles without going en route? And we actually had several meetings with the local utilities. There's 2 in Connecticut that were impacted, the transit agency, as well as the Public Utilities Regulatory Authority. And we had months worth of meetings trying to address, what the impacts of utility demand charges on transit agencies in the state of Connecticut were. And they're now opening a new rate case, and we're going to see some, I think some interesting rate design coming out of that, primarily for the transit agencies, because they are a little bit more unique than some of the other types of charging infrastructure.
Yeah.
But I also think pairing battery storage with on-peak charging is one thing we can do as well, whereby you shave that peak because you combine battery storage with that 500 kW charger that's going to hit, at a bus stop and charge for 10 minutes, but you're really going to be charging from the battery, not from the charger, and then you're going to keep charging that battery all day long. So I think there's other technologies that we're looking at that can help minimize demand charge.
Yeah, and there are some jurisdictions where demand charges really do make up the bulk of the electricity costs. Electric fleets, electric trucks in particular, are really good customers of electricity, right? They're using a lot of kilowatt hours every day, all day, 260, 360 days a year. We've done studies for utilities that show if you get fleets to electrify, because they're using so many kilowatt hours, it can actually reduce residential electricity rates because you're amortizing the overall grid system across far more kilowatt hours. And I think, over the next 5 years, I think there's going to have to be some policy shifts, some regulatory shifts that sort of, if you are paying a high demand charge, that you're paying the lower kilowatt hour charge, because I think fleets are going to, in jurisdictions with high demand charges, fleets are going to be paying a disproportionate share of their electricity costs. And there's an opportunity to encourage them in a way that lowers the price for, the average residential ratepayer.
Right.
So Craig, you were asking a question about sourcing. Was that in the context of alternative financing for infrastructure? Is that where that question was leading?
Well, okay, so they were asking about sourcing of energy, which, that could be through an energy marketer perhaps, but also it was in reference to microgrids or battery storage. So, that might also be
Sure.
Reducing electrical costs, maybe reducing demand charges by using microgrids of some sort.
Sure. Well, the big piece about microgrids is a lot of times you're seeing the buzzword energy as a service, infrastructure as a service. You're seeing more and more in the market related to transportation and service, where you're actually bundling the vehicles and the infrastructure piece. But kind of focusing on the microgrid piece of it, there is a contracting methodology that's really been around for really quite a while. I'm not sure if the folks on this call are familiar with power purchase agreement, where essentially it is you have have somebody that brings in the capital, that holds the paper, that guarantees the performance of the off-taker. Now, traditionally, power purchase agreements have been used by, let's say, enterprises, universities. There's been some examples of corporate usages, military, those types of things. But instead of the off-taker being those entities, the off-taker is going to be the fleet. The nice thing about many of these types of power purchase agreements or infrastructure as a service is they can be deployed with a very limited or no upfront capital. And they're fairly. They can be 5, 10, 20, 15 years, however that wants to be set up, where there's a guarantee of performance, of output capacity, guarantees of uptime, and also, bundling the operation and maintenance piece of it. That's really the future, because I mean, ultimately, the vehicles are going to be paid for a certain way, and this vehicle infrastructure as a service is something. There's actually a lot of capital out there right now to provide that. So that's where we see the future of the infrastructure piece, is as a service.
Great. You know what? We have a few more minutes, guys. I have more questions than we have time, so I'm going to go ahead and just move on to the next question. This is specific to New York City, but I've heard the same question in Western New York recently. And the question is, another issue in New York City is acreage to set up chargers. Our fleet parks several vehicles on the streets throughout Manhattan. So what are your thoughts on on-street charging, perhaps, for fleets?
I'd be concerned about security for the vehicles would be my first thing. Maybe my
I think, so I've worked on some on-site street side charging. It's expensive, right? So you're in the cityscape, and doing it in New York City is even twice as expensive, right? So you're in the cityscape, you got to like dig up the streets, you got to put a charger on the outside of a building. That makes it really hard. I have, there are places, and logistics is getting more and more outsourced. And so you see some people taking their trucks home, right? Some drivers take their trucks home at the end of the day, or some drivers take or if it's a third party providing you the fleet service, they're taking it to some other facility at the end of the day. And so we have seen, use cases where, while that truck is at your loading dock, to get enough juice into them for them to do their daily routes. And maybe they're only at your loading docks for 2 or 3 hours a day, but sometimes that's enough to hit their operational range. Right? It's not as good as the truck sitting there all night long, but we're working on a project in Paris, and they, everybody drives their truck home at the end of the day. That's how they get home. Right? The transit system doesn't start until at 4 a.m. and that's when the vehicles have to go out. And so, the vehicles really only are at the loading docks for 3 hours a day, and they've just designed the charging to match that profile.
Great. Well, thank you. Next question. How difficult is it to get plans approved, and what are the major drags on the development process time frame?
Drawings approved through a permitting process?
Yes.
Yeah. It's different. I mean, one of the elements, there's two things that I'll throw in a couple elements. One is, in a lot of instances, the folks that are reviewing it may not, now it's going to change, but may not be familiar with the electric vehicle electric charging stations. So anytime that you're bringing new technology into the market, there is that education of the folks that are reviewing, and certainly the inspectors, as codes change, things like that, you're going to see that piece of it. But also from a standpoint, let's say there might be 4 or 6 or 8 or 10 different departments within that permitting process. It needs to be looked by each department as you make change, as those comments are made, and it comes back, and it goes back to the to the engineer of record. They may have to make modifications and go back. So really, the challenge is making sure that you understand the requirements and the process, and having that relationship with the authority having jurisdiction up front is a key element to it.
I also think that there's a role for utilities to make it easy. And traditionally utilities haven't, right? they don't make it easy for you to apply for the more power or permit the more power or get and so one of the things that we're doing for some of the more progressive utilities is, well, how do you establish the work processes in place to make it easy for fleets to electrify? How do you tell fleets where there's available power? So there's no surprises when they get the letter back saying, well, there's a substation upgrade required. I think all of those things are things that on the utility side that as an industry we can be doing to really help fleets use more of the electric infrastructure that's available, and make that process easier. But I don't think we're there today as an industry. I think it's something that we can aspire to over the next few years.
All right, so I'm going to put one more question in, and then we'll go ahead and wrap up after this one. And I'm actually going to sandwich two questions together again. So we had two different questions. One is wondering if you could speak to the rough vehicle to charger ratio for depot charging medium and heavy duty vehicles. And the second one is, can you go into detail on exactly which vehicles and classes can rely solely on 15 to 19 kilowatt level 2 charging?
So I can probably take a stab at that. So the ratio, it depends on the operations. If you're an overnight operation, if your vehicles are charged overnight, sitting there overnight, and they're sitting there overnight for 12 hours, it's possible for you to get 2 vehicles charged off the same charger comfortably, right? 3 if you really want to squeeze it, right? It doesn't leave a lot of operational flexibility, but 2 definitely is possible. When you have a fast charger, right? The fastest, most powerful charger you can get your hands on, right? So right now that's a 350 kilowatt charger, and soon it'll be a 500 kilowatt charger, and after that it'll be a megawatt charger. I don't like to see utilization rates above 40%, because cars have to come in, cars have to go out. It's hard to you don't want cars queuing, right? You want to be able to have an electric vehicle, come up to the charger point and not have to wait for the vehicle in front of it. So if you can keep utilization rates of those sort of mega chargers, those opportunity chargers, less than 40%, I think it solves a lot of operational headaches. And then on the 15 kilowatt chargers, I wouldn't charge a heavy duty vehicle on that, but if you had a medium duty vehicle that didn't have a long range, like 75-mile ranges, it's possible.
Yeah, it really depends on the duty cycle, the route, and what you're using it for the fleets. But I wouldn't disagree with anything that Alex just said. I mean, the ABB charger, the 150 kW charger with 3 charging dispensers, is a nice solution that enables you to sequence one charger to three vehicles if you have the time to charge them that way. So, I mean, that makes perfect sense. A 1-to-1 is not necessary.
Good. I think you guys got right to the heart of the question, which is, do we need a 1-to-1 ratio, or can we do it less? Is there strategies available out there?
Yep.
So, yeah, well, I wanted to go ahead and just wrap it up at this point. So thank you to the 4 of you for presenting on charging infrastructure. I learned a lot today, and we had quite a few attendees, and I think they're appreciative of your time as well. So I want to thank everyone who's attended the webinar today, and I hope this was useful to you and that you learned a lot. We do the 6 Clean Cities coalitions throughout New York, from Buffalo to Long Island. We all coordinated this together, and we thank you for joining us. Our contact information is shown here on this slide. You'll also be able to find these presentations on each of our websites being posted. And we are going to be forwarding a recording of this webinar as well to all the attendees. So keep an eye out on your email box from us. We're going to still be working out through the rest of the afternoon and evening so that we can get this content in your hands. So with that, I'll go ahead and wrap up today. And thank you very much, and good night.
Thank you, Craig.
Thank you, everyone.